This is Math for College Readiness, Semester A, Unit 1, Applications of Ratio and Percent. I'm going to go over the guided notes for this lesson. And first we have solving ratio problems. So a ratio can be written with a colon, like A to B and C to D. They can be written like fractions. So they're proportionate, okay? Here is an example problem. Ryan discovers the ratio of tigers to lions at a popular national park is 3 to 4. There are 24 lions at the park, but he doesn't know the number of tigers. So first we know tigers to lions is 3 to 4. So tigers is on top and the 3 is on top because we have to make sure that they match up in the order in which they were written. And then lions is on the bottom and 4 is on the bottom because lions was mentioned second. And we know that there's 24 lions, so I'm putting that on the bottom along with lions. Okay, so everything matches up. We don't know how many tigers there are, so that is X. And then we think, okay, well, how many times does 4 go into 24? 6 times. So 3 times 6 is 18. There would be 18 tigers at the park. The guided notes show you a different way to solve it, which is absolutely fine. Do whichever way makes sense to you. Cross multiplication. So this is another way to solve it. You could multiply 4 times x and 3 times 24 and then end up dividing. So there's a few different ways that you can solve these proportions. Here is another example. Hank is building a dog run for his dog. He wants the ratio of the length to the width. So length is going to go on top, width is going to go on bottom to be 5 to 2. So the length is 5, the width is 2. If he builds the dog run, so the length is 10.5, so we put 10.5 on top for length. Which equation can be used to solve for the width? So basically right here, they're showing, they isolated the W, the variable, to get the W by itself. So if we were to cross multiply, it would be 5W and then 2 times 10.5. And then we could divide both sides by 5. So 21 divided by 5 is 4 something. I gotta use my calculator for that. So, I think it's 4.2. Yes, 4.2. So the width is 4.2. Okay, so percent problems, you can also use cross multiplication. Peter bought a soccer ball for $20. He paid an additional 10% sales tax. What's the total amount he paid for the ball? So a percent can be written as a fraction with 100 as the denominator, because percent is always out of 100. So if T is the tax amount, then the tax percent over 100 equals the tax amount over the price. And the tax amount, and this is 10. So we have 10, like 10% over 100 equals the tax amount T over 20, which was the cost of the ball. And if we cross multiply 20 times, well, we have 20 times 10 and 100 times T. So, and then 20 times 10 is 200. 200 divided by 100 is 2. Oh, I'm skipping. T equals 2. Another way to look at this is if 10% is the tax out of 100, and we want to know how much the tax was, and 20 is the cost of the ball, 20 goes into 100 how many times? 5 times. So 10 divided by 5, we could say 100 divided by 5 is 20. 10 divided by 5 is 2. So that's another way to look at it. So the tax is $2. Peter paid $20 plus the tax, $2, for a total of $22. Discounts. Lena wants to buy a pair of shoes. The marked price of the shoes is $60 and it's 40% off. So 40% is the discount, which is right here out of 100%, or the total 100. 60 is the cost of the shoes and D is the discount. So using this method of cross multiplying, we could do 60 times 40 equals 100 times D. So 60 times 40 is 2,400. We're going to divide both sides by 100. That cancels out the 100 on the right side. So 2,400 divided by 100 is 24. So the discount is 24 off, $24 off. The amount of the discount is $24. The discounted price is the difference subtracting of the marked price and the discount. So if it was originally $60 minus $24 equals $40.36. So she has to pay $36 for the shoes. Another way of doing this kind of discount percent increase or decrease problem is if I know it's 40% off, then it's going to be 60% of the original price. So usually you can do this in your head. It's 40% off, it's 60% of the original. Okay, so then I could just say 60 times 0.6 for the original price to get $36 would be the sales price. So that's two different ways that you could do this. Okay, so percent increase and decrease. The formula for this is the percent change is the amount of change over the original amount times 100. So let's go down to the example. Last year, Joe earned $10,000 working part-time at a craft store. This year, he's going to earn $12,000. So the difference is 12,000 minus 10,000, or $2,000. And we want to know how much percent increase or decrease that is. So we have $2,000 over the original 10,000, how much he made the first time. And they're cross multiplying here. So 2,000 times 100 on the right. And then 10,000 times the percent change is what we're looking for. I don't know, this is set up weird. So I would say I would reduce this first. I'm going to cross off this and this. And then 100 times 2 is 200 divided by 10. So it's a 20% increase between last year and this year. Okay, so percent error, this is going to be similar to what we just did. Okay, so the estimated height of a bookshelf is 8 feet. It is actually 8.64 feet tall. So you're finding the difference on the top. See, right here's the difference. You just subtract it, and then you put it over the actual amount. So the bookshelf is actually 8.64 feet tall. So 8.64 minus 8 is 0.64, and then you divide it and multiply, and that gives you your percentage of error. So if I do 0.64 divided by 8.64, I get 0.074, and then it like repeats. And then to make it into a percent, I multiply it by 100. So my percent error is 7.4, rounding it up. Okay, let's look at the next one. The estimated length of a laptop is 12 inches. It is actually 11.4 inches. So first you find the difference. 12 minus 11.4 is 0.6. And you divide 0.6 by the actual length of the laptop. 11.4 is 0.0526, and then it goes on. And then multiply that by 100, and I'm just going to say, I'm rounding it up to 5.3%. And last one, the estimated weight of a jar of peanut butter is 0.5 pounds. It actually weighs 0.52 pounds. So to find the percent error, you're going to subtract 0.52 minus 0.5 is 0.02. Divide that by the actual weight, which is 0.52, and I get 0.03846,154. Multiply that by 100, and I get 3.8% error. So this lesson went over ratios, cross multiplying, percent increase and decrease, and percent error. Let me know if you have any questions, and I hope to see you in the next class.